Hello, good morning, first graders. How are you doing? Did you enjoy your Monday? Was it okay, the practice that we had on spelling? Thank you very much for the homework that I have been checking. Very well done. Some of you still absent, like Arlette. It's been ages ever since I don't know her, but well. It's okay. Today is Tuesday, June the 2nd, 2020. And as we have every single week ever since this coronavirus stuff, we're going to have our science practice. Remember that you can always double check the contents of this review on your Shake Up Science book, both the student book and workbook, as well as on your contract. That being said, let's get started with our review on weeks 1 and 2. Okay, bear in mind that we had already practiced these sections on your contract, okay? And on the contract, we had the chance to study on the first week. It was from page 100 to 103 on Shake Up Science book. We said that we would talk about motion, speed, and location of objects. Bear in mind that we answered questions related to description of location, position, motion, speed, and the different categorization of types of speed, constant speed and variable speed. On week 1, we had how can a map help you describe the location of an object? I think it was very obvious because anytime we get lost, for instance, we want to go to a part of Querétaro or nearby one of the 18 counties this state is divided into, and we don't know exactly how to head towards a place in concrete, we use that GPS. What is that GPS for? It's a drawing and it helps us get to where we're going to. So, how can a map help you describe the location of an object? Because it is a drawing of all or a part of an earth surface and it's given you directions. There's going to help you. That is going to serve as a guidance on where you have to go, okay? Now, in question number 2, we had what the meaning of position was, and it's the object's location or where something was, okay? Here's missing the apostrophe, excuse me. So what was motion? It's the action of changing position. Obviously, if you produce motion, you create movement, and the position's going to be altered, right? Now, the meaning of speed was the rate of speed, that is to say, description of how fast or slow an object can go or change from position. Bear in mind the differences and analogies between constant speed and variable speed. Obviously, we had examples like an airplane. I gave you that example because it normally flies steadily in a single, not direction, at a single speed, okay? It's steady, it's permanent. But when it comes to a roller coaster, imagine you would go on a roller coaster and it will always go in the same, it has the same direction, but at the same speed. Would be kind of boring. The exciting thing is that it has spins and turns and curls and things that you're not expecting to happen. Now, I found this very interesting video. Yeah, I know you're gonna tell me that it's for toddlers, it's for babies, it's not for you. But it's a song. You don't have to sing it alone. Quoting John Michael, it would be so humiliating, right? But the first part reflects a little bit upon the subject that we have been working on. Let's pay attention.
Motion is a change in position.
Motion, what is motion? It's a change in position.
Like forward, backward, up, down, and through.
You see the different kinds of motions. Up, down, and through. Remember, we have linear position. It can go on zigzag, it can go straight, it can go curved, or like a merry-go-round, a roller coaster.
Things can zigzag or go straight. Even circular is great. When you know the way, you'll know just what to do. Things in motion always move in a direction.
Things in motion always move into a single direction or a direction in concrete. And we have the cardinal points, so we have north and south, east and west.
Traveling north, east, south, and west, they can go left or go right till they've traveled out of sight.
Exactly, they can go left or right, they can go out of sight.
Automatic math will put this knowledge to the test. Motion can be measured by its distance, just as motion can be measured by its time.
You see, motion can be measured by distance and by time. That's very important to know.
Things can go far or go quick, and as miles and minutes tick.
You see, things can go fast or slow at a different speed.
Understand it, as you'll notice rhyme. Let's sing together.
Okay, that would be too much. But you know the important part of this smart clip had to do exactly with the things that we reviewed on week number 1. Position, motion, speed, and the kinds of or categories of speed that we happen to count on. So, science practice, handling basic concepts. Remember in one of the pages, I guess it was page 102, I'm not very sure about it, when objects move, it says, look at the picture of the children playing. How would you describe the position of the boy? So, in this case, we have 2 boys. In the original picture of the book, we had a boy on this side and a girl on the other side. That's what it says. Position is an object's location or where something is. You might say, the boy's position is on the ladder beside the slide. That's what we can see. Now look at the girl. Use your imagination. Let's suppose in a hypothetical situation this is not a boy but a girl. Now look at the girl sliding down the slide. The girl is in motion. That is to say, she has some kind of movement. And motion describes the girl's movement from the top of the slide toward the bottom. So those are basic concepts that we also handled in the first week of Contract 6. Now, what animal is this? I know, maybe it's a very basic question and it's like, you're insulting us. No, that's not the idea. The idea is to know that this animal, I guess it's a hamster. I don't think it's a guinea pig, but well, it's an animal, right? And is spinning in circles, but in a steady position. It's creating some kind of friction. Why is that? Because the spinning roll has some kind of texture, okay? And that's what we're going to talk about. We're going to have a freshen up on what motion was, how force affects motion, and what gravity was. Remember that on week 2, and it was supposed to cover from pages 104 to 105, we had questions like, how does friction affect force? Because when you apply contact force to an object, it changes its speed and direction. Let's suppose this animal were not, yes, it's correctly said because it's a hypothetical situation. Let's suppose it were not spinning around in circles in this steady object. This has a surface, and the surface has a certain texture. And this is preventing the animal from going faster. Imagine that he is on the loose, free, without any wheel. Probably he will go faster. That is to say, the speed rate would be affected because there would be no friction. When the animal is in direct contact with the ground, most probably he can go faster. And that's how friction affects forces, and therefore it affects the speed rate. Now, what is the meaning of force? The push or pull that can change the motion of an object, as we can see on the GIF that I attached in this presentation. Now, how does an object gain force? Obviously, because of the intensity of the contact force. Remember the clip that we had on that week? We had a clip where a guy was showing us how to slide. And first, he was sliding only with his socks on. He was not wearing his shoes. By the time he decided to wear his shoes, the movement was kind of different. Why was that? Because it was a direct friction with the ground. But on the first instance, when he was just wearing socks, obviously friction made it move smoothly, and it gained more force, therefore gaining more speed. Now, we were supposed to name 3 objects and explain how they can affect motions. The ones that I chose were a soccer ball, a toy car, and a baby carriage, and how that affect the motion. Soccer ball, it depended on the kicking and the contact force, okay? Depending on how much intensity the soccer player applied on his kicking, obviously that was going to affect the motion of the ball. Now, when we talked about toy car, it depended on how fast you push or pull it, right? And it also depends if it's running on batteries. Probably when you run it on batteries, you can control the speed, the motion of the object. And the baby carriage, how quickly or fast you can push the object. Remember, you're carrying a baby. When you're carrying a baby, you have to be careful. It also depends if the baby has just eaten, you have to go slowly. If the baby hasn't eaten, most probably you can go faster, or if you're in a rush, probably you will have to push it harder, right? So that's the way it works. Now, what is the technical definition for the word force? We also invested time studying on this definition, and we knew that force, technically speaking, was a push or a pull. In other words, it moves something toward or away from you, as we can see it on the picture. I recall when I first took Mishka around the neighborhood, and you don't know, frantically speaking, you didn't even know who was walking the other around. You don't know if Mishka was walking me or I was walking Mishka. Bear in mind the key words that we studied from those first 2 weeks, like force, remember, a push or a pull, friction, when you have direct contact with the ground, magnetism, this attraction of the opposites, iron, which is the main element, the magnet, which makes the attraction, and steel, which was the basic material, because when things were made of wood, they would repel, right? We talked about the causes of motion, like when we talked about baseball player hitting the ball. The bat pushes against the ball. The bat has all the power of the player's swing. Because of the intensity of the usage of the bat, then we talked about force. Force is a push or a pull. Most of the forces you use are contact forces. Most of our everyday action when it comes to forces are contact forces. When you hit a baseball with a bat, the bat force changes the speed and direction of the ball. If the bat doesn't make contact with the ball, then changes cannot occur. And then we had a diagram. The force is a push or a pull. We had an example, a bat hitting the ball, or a bat must make contact to push. In conclusion, a bat's push is a contact force. As you can see on the GIF, there's this animal pushing the cart. Imagine that he didn't have the other puppy in that cart. Do you think the dog would go faster or slower? What do you think, Barbie? If this dog, okay, were pushing this shopping cart without the other puppy inside, do you think he would go faster or slower? Obviously, he will go faster because forces affect motion, but also the mass and the weight. So effects of mass and friction. A force can change an object's position or the direction of its motion. A push by the man can cause the shopping cart to start moving. In this case, it's not a man, but another doggo. If he then pushes to the right, the moving cart will change direction to the right. He's going all the way up, that is to say, straight, in a linear position. But if the dog turned around, he would either go on the left or to the right, okay? How much an object changes its direction and speed depends on how much force is used. A large force will cause a greater change in motion, obviously. Remember when we had that example from the student book where we saw 2 shopping carts? The first shopping cart was full of groceries. If it's full of groceries, it was kind of heavy. So weight and mass interfered in the reaction. The person will have to apply more force, and the more force you apply, the faster the motion. Okay? How an object moves also depends on its mass, as I said beforehand. When the man starts pushing, that is to say the doggo, his cart is empty. He doesn't need much force to push it, but the poor doggo is pushing another dog inside the shopping cart, and he needs a greater effort, right? See you on the second part of this video. We will continue double-checking concepts of the contract number 6, weeks 1 and 2, So stay tuned and you will also see instructions for homework doing.